All right, so here we go. So probability of A given B is 1/2. And probability of A and B is 1/6. So what's the probability of B? Well, probability of A and B is the same thing as saying probability of A given B times the probability of B that's happening. So I know that this here is 1/6. I know this is 1/2. So I can figure out that this is 2/6 or 1/3 is probability of B. All right, so here we go. So more probabilities here. So I've got 10 semifinalists, 7 men and 3 women. So I've got 2 semifinalists, one after the other, there, and we want to find the probability that both of them are women. So what's the probability that both of them are women? So what I'm thinking is woman 1 and woman 2, right? So what does that mean? That means that I had to pick woman as the second one, given that the first one was a woman. And so that means I have to multiply by the probability that the first one was a woman. Okay, so let's figure out this first. What's the probability the first one was a woman? Well, there's 10 finalists, right? And there's 3 women, so that's 3 out of the 10. So what will this be? Probability that the second is a woman, given that the first is a woman. So out of the 10 semifinalists, I've already chosen one of the women, so I've really got 9 left to choose from. And so, and I've already chosen one of these 3 women, so there's only 2 of those left to choose from. So there you go. All right, what's the probability that both are men? So probability of man 1 and man 2. So same thing, probability of man 2, given that the first one's a man. Okay, so probability the first one's a man. So there's 7 out of the 10. And then probability that the second one is a man, given that the first one's a man. So I only have 9 to choose from. And I've got 7. I'm picking 7. Hold on a second. I chose one already. So I need to have, I'll have 1 less to choose from, so I'll have 6 men to choose from since I've already chosen one of them already. All right, what's the probability that 1 is a woman and 1 is a man? All right, so I've got the probability that the first one's a woman and the second one is a man, or the probability that the second one is a woman and the first one is a man. Okay, so let's do the first one is a woman. So if the first one's a woman, so that means I have 3 out of the 10. And then the second one is a man, so that means I have 7 out of the 9 left to pick from, right? Or then if I chose, okay, the second one is a woman and the first one is a man. So if the first one is a man, that's a 7 out of the 10. And then the second one is a woman, so that out of the 9, I have 3 out of the 9 left. All right, how many ways? Oh, how many ways? That takes us back to old times. How many ways? Combinations. So notice the difference, right? So this was probability. Combinations to have 1 male and 1 female. So out of the 7 men, pick 1. Out of the 3 women, pick 1. So multiplying. So I threw that in there to make sure that you're remembering how to do combinations as well. All right, almost done here. So here I have 3 exclusive events where all 3 of these things add up to S. So probability of A and B are 0.4 and 0.2. So that means probability of A plus probability of B. That gives me 0.4 plus 0.2, so that gives me 0.6. Is it possible this could have a 0.6? No, because all 3 of these, probability of A, B, and C, since all of it makes up the whole set, has to equal 1, so no, not possible. All right, last here, so I want to make sure that I've got playing with these correctly. So I want to find out the probability of U, which will be 1 minus 0.3, so that's 0.7. And there's my probability of V. So I want to play with this correctly, right? So I want to say this is the same thing as U intersect V complement, right? Which is the same thing as saying 1 minus probability of U intersect V. So I know that this is 0.4. So that tells me that this here is 0.6. Okay, so probability of U and V is probability of U plus probability of V minus probability of U and V. I just figured out that that's 0.6. This is 0.7. That's 0.6. Whew, so I get 0.7. All right, last one, pigeonhole. So if I've got all these different names, I've got Zeke, Wally, Linda, Lee, David, one. So I've got how many different combinations? 3 and 2 and 3. So that gives me 18 different combinations of names, right? All right. And I've got 19 people. 19 people. So I've got 19 people, and that's going to be just 1 times 18. And so that means my K is equal to 1, right? So I can have all the different people or all the different combinations laid out. And so that must mean K plus 1 or 2 have to have the same name. Complete name, first, last, and middle.